Hello, this is exercise 12F.2. We've already seen a bit of 12F, but we're going to second look at it because we're now finding areas to the y-axis. I think we've seen a bit of this in the past, so hopefully this should be fairly easy. But we're obviously doing it with harder functions potentially. A few words. We are sometimes asked then to find this area not underneath the curve, but to the left or the right of the curve. When we are doing this, we are going to essentially find an integration slightly differently to what we do normally. And you'll notice down here, but I know there's a load of writing, but basically we are going to find the area of x dy. Normally, of course, we find the area of, if I find the area underneath the curve, we find the area of y integral of y dx. So notice how the letters have switched places, and with that though it's not x numbers now. We're not interested in this number here and this number down here. We don't want these two numbers, we want these y values instead, so we do it between c and d. Obviously we don't leave it as x. X is a function of y, and we'll see that again in a bit. So here's our first example. It says find the area between the curve y equals root x, the y-axis, and the lines 1 and 2 on the y line. Now look, straight away you think, what does it look like? This is one actually you should know. That's what it looks like. And we are doing it, it says, between y equals 1, and it's not very obvious where 1 is. And there's 2, there's 1, I suppose. So we want this tiny little area here. Well, it looks tiny on my big graph, but you get the idea. That's what we're trying to find, that area there. And you'll notice it's as soon as you draw it, as soon as you get given these y values, it's to the y-axis and not to the x-axis. So it's the integral of x dy. That's what our formula is between the values of 1 and 2. And you'll notice we might be lucky and be told what x is, but we might not be. We are here told what y is. So I've got to rewrite it, and if I rewrite it, the square root becomes a square as I move it over, and I get x equals y squared. And that's good enough for me now to do it. It's the integral of y squared dy. So having written x, I change it into y squared. I now integrate y squared, I get y cubed over 3 between the y values 1 and 2. So I put 2 in, I get 8/3. Put 1 in, I get 1/3. Take 1 away from the other, I get 7/3. That's quite nice. 7/3 was the answer. Okay. This one I've already drawn for you. Now this is a bit weird. I mean, again, it could be one that they don't draw for you, or it could be one they do. So a lot of exam questions they do draw it, but it says find the exact area enclosed by the curve y equals log of x plus 3. And I suppose it's because it's such a horrible little area I've got to find it. So I think it's this little thing here. That's the line y equals 1 there. It says find the area enclosed by the curve. The curve, and this is obviously y equals log of x plus 3, and the y-axis, this line, and the line y equals 1. It is that area. So I suppose the very first thing I need to do, I've got my lower boundary for y, I need my upper boundary for y, and that's when this curve hits the y-axis, and it hits the y-axis when x is 0. So when x is 0, y equals the log of 0 plus 3, which is obviously log 3. Natural log of 3, of course. So now I have my points. I can find my area by finding the integral of x dy between y equals 1, this line, and y equals log of 3. Of course, I don't want to know what x is. I've got to undo this thing. So let's do it up here. It's y equals the log of x plus 3. Move the log onto the other side. I get e to the y equals x plus 3. I get e to the y minus 3, and I'm going to chuck an x on the front. So that's what my x is equal to. So this is really the integral of e to the y minus 3 dy in between 1 and log 3. Notice it says, by the way, exact there. I just read that there, just highlighted it in my mind. Integrate. The great thing about e to the y, you integrate it, it's still e to the y. 3 becomes 3y. That's between 1 and log 3. So, okay, that's good enough for me. So put log 3 in. It's e of log 3 minus 3 log 3 minus, I'll put the 1 in. That's e to the 1 minus 3 times 1, which is 3. Now e to the log disappears, so that's 3 minus 3 log 3 minus e, that's plus 3 I think, plus 3. So when I do this, I get 3 plus 3 is 6, minus 3 log 3 minus e. Don't know what the answer is. Well, I've got minus e. That was nearly a mistake from my part, I think. You'll notice this area is actually a negative area. So if I was to chuck this into my calculator, I'm going to do it now. Because it's on the left-hand side, everything over there should be negative, and everything over here should be positive. So if I just type it in and just confirm that. So if I do 6 minus 3 log 3, close bracket, minus e, you've got to be a bit careful, e, that's e to the 1 really. Yes it is, it's a negative. So this is negative 0. Only a very, very small piece, so obviously a very small number. But you'll notice it's negative, and it doesn't ask me for the integral, it asks me for the area. So the area isn't that. The area is, I've got to change the sign of all these. It's minus x plus 3 log 3 plus e. Oh, I'm pleased I spotted that. Well, I didn't spot it, they did. Okay, just be aware that, oh, if I got that all the wrong way around. No, I've now got it right. So I've changed these signs, and therefore I've got the same as they have got. Yes, I have. And the final example I've got for you here. Find the area enclosed by this curve, y equals the square root of, no, 2 times the square root of x minus 1. The x-axis, the y-axis, and the line, and that should say the line y equals 6. So straight away, chuck in the calculator, what's it look like? That's what I got when I've done mine. And it says we want the area between. Okay, it's the y equals 6. Well, obviously 6 is there. It says do it between the x-axis. I think it's this area here I want. Okay. Obviously that is 0 because it says the x-axis. That is 6. I don't have to find those points. So it's relatively straightforward. It's the area, the integral between 0 and 6 of x dy. Because I'm going to the y-axis, it's x dy. What is x? Well, I don't know yet. Y equals 2 square root of x minus 1. Move the 2 straight away. Y over 2 is the square root of x minus 1. Move the square root. Y squared over 4. Notice I've squared top and bottom. Equals x minus 1. Move the 1. X equals y squared over 4 plus 1. Okay, I like that. So this then is become the integral from 0 to 6 of y squared over 4 plus 1 dy. Integrate it, that gives me y cubed over 12 plus a y between 0 and 6. And if I put 6 in, I get 216 over 12 plus 6. Don't know what that is, I'll do it in a bit, but certainly when I put 0 in, I get 0 out. So 216 over 12. 216 divided by 12 is 18, plus 6 is 24. I reckon it's 24 square units. Let's see what the answer is. 24. So yeah, I was right. That was the last example. Exercise 12F. This was our second bash at this. Only specific questions, question 2, 7, 8 and 12. And there might be some on the miscellaneous exercise as well. But hopefully that is okay, and we'll get a good lesson out of that. Thank you.